November 19th assignment, Systems of Equations, Exercise C, and Application of Systems of Equations cards. We're just going to go over a few of the problems from the assignment with you, just in case you have some questions. I'm going to scroll down. Numbers 1, 2, and 3 are simply plain systems problems, so you're just going to answer. Whether this system has no solution, one solution, infinitely many solutions, or cannot be determined. Just remember you can put those equations in your calculator to look for intersections because you're looking for intersections. Number 4 is also looking for the intersection. So I'm going to go down to number 5, and it says the equations y equals negative x and y equals negative 2x plus 4 are graphed on the coordinate plane. Which of the following accurately identifies and verifies the intersection point that satisfies both equations? So you have your equations here, and you're able to see your point. You're able to see your intersection point, which is right here. And so if you know how to label points on the graph, then you already know your answer. But notice they have negative 4, 4 as an option and 4, negative 4. So obviously B and C are not going to be the answer because you're looking for this intersection right here. But if you get confused on your X's and your Y's, then you can also put this into your graphing calculator. And so you would go to the Graphs app. It's this one right here, the second one from the left. And you're going to type the first equation, which they told us the equation's y equals negative x. So you're going to type negative x, arrow down to type in the second equation, and type in negative 2x plus 4. And you can hit enter on that one. And the intersection is quite visible on there as well. And so if you want the calculator to give you the intersection number, you're going to hit menu and then analyze graph and then intersection. So menu 6, 4. And I'm going to drop that dotted line somewhere to the left of the intersection and then move my mouse to the right and click the mouse pad again. And I can see that the intersection is at 4, negative 4. Okay. I'm going to go to number 6. And number 6 says, Olivia and Stan are finishing their summer reading assignments for their 9th grade language arts class. The graph shows the linear relationship between the number of pages that each of them have left in their assigned reading and the number of days that they have taken to finish their assigned reading. On which day will Stan and Olivia have the same number of pages left to read? So we're wanting to know, when are they the same? So, and it says on which day will they have the same number. So where are they going to be the same? At this point where they intersect. And if you pay attention to, we're looking for which day, days is on your x-axis. So that would be your answer. So the answer is 12, day 12. Again, if you struggle with writing your equations, I'm sorry, with your values, you could write your equations for each one and then put that in the calculator to find your intersection point. Okay, so number 7 is just asking for the intersection point. So remember on number 7, just like the other ones too, when you're graphing, it's x, comma, y. So start at the origin and either move left or right, and then go up or down. And that's where you get your numbers for your x, comma, y. Okay, I'm going to go a little bit further down to number 11. Number 11 says an airplane is at 19,000 feet, descending at a rate of 40 feet per second. Another airplane takes off and ascends at a rate of 70 feet per second. After how many seconds will the airplanes be at the same height? What is this height? So it's important that we know one airplane is at 19,000 feet. So the starting point is 19,000. But that airplane is descending at a rate of 40 feet per second. Descending means it's going downward, so we're subtracting altitude or we're subtracting height. So it's minus 40 and it's feet per second, so that's going to get the x. And we probably need to talk about the x and the y. We have two different units. We have feet, which is our height, and we have second, which is time. When you're trying to figure out which one is going to be x and which one is going to be y, I know you've talked in science about independent and dependent variables. Your x is your independent. So what is going to continue at the same no matter what? And then y has to depend on x. And so basically time is almost always x because time is consistent and it moves at the same rate. Since the height changes as time goes on, the height is dependent on the seconds or the time. So x has to be time and y will be the height. Okay, so the first equation we said was y equals 19,000 minus 40x. The next equation comes from another airplane takes off. When a plane takes off, it's taking off from the ground, so the height is 0. And it's ascending. That means it's increasing. So it's going to be a positive rate of 70 feet per second. So y equals 70x. So I have my two equations, and it wants to know after how many seconds will the airplanes be at the same height, and what is this height? So I'm going to find the intersection, and the number of seconds will be the x value at the intersection, and the height will be the y value at the intersection. So I'm going to go to my calculator. And I need to type in those two equations. So I'm going to hit Control W to wipe out what I had earlier. Then I'm going to go back into my graphs and I'm going to type 19,000 minus 40x. I'm going to arrow down to type in my second equation, which is 70x. Now, as you can see on the screen, I only see part of one line, and that's because the numbers are so big. So what I'm going to do is hit Menu, 4 for window zoom, and then A for zoom fit. And I still don't see an intersection, so I'm going to have to zoom again and zoom out. And I'm going to keep my origin as the center, and I'm just going to keep clicking on the origin to continue zooming out until I see the intersection on the screen. So about 4 or 5 times you're going to need to so that you can see the intersection is right about there. Then you're going to say Menu, 6-4, Analyze Graph Intersection, and then draw your box so that you can see the intersection in it. And it wrote it in scientific notation, but this is my answer. So it's after 173 seconds. And this is my altitude or my height, but this is the same thing as 1.21 times 10 to the fourth. And you can actually change your settings by going 9, and where it says float, you can change that to a bigger number so that it can show more decimal places, which I did. So I have 172.7 seconds. It will be at 12,090.9, which if you round it up, it's at 173 seconds. It will be at 12,100 feet. And I will show you that on the graph one more time so you can compare your answers to what we got on the graph. If you have any questions, please email your teacher. Thank you.